All right, so today we're going to be talking about evaluating expressions. So evaluating expressions means that you're giving value to an expression. Expression being a collection of symbols together based off some operations. For example, x plus 2 or 3x plus 2 or the square root of x or negative 9, x to the second power. All of these are expressions. Even if you added them all together or subtracted them from each other, that would be a new expression. So when we evaluate them, we give value to that expression. Well, how do you give value to something that's variable, meaning that it can change at any time? So those x's or other letter or a question mark, we don't know what that is, right? It could be any value. I can plug anything I want in there. Um, if it's just an expression, it's not necessarily equal to anything. Um, then how do we give value to that? Well, there's two things that are going to be very important for you to know in order to do. The first one is substitution. So a substitution means is that, let's say I say that x, fine, let's see what x plus 2 is if I know x equals 5. Well, if I know x equals 5, you would say, oh, that's 7. Well, how'd you get that? You would say, well, x is 5, and if we add 2, we get 7, and we're done. Yeah, well, what you just did is called a substitution, and you also evaluated the expression. So substitution is just like how it is anytime you've ever seen a substitution. You see substitution in a basketball game. One player goes in for another. They sub for them. When we have a substitute teacher, one teacher goes into the classroom to take place of the other one. Anytime you've seen substitutions done, something takes the place of something else. So in this case, x has its place taken by the 5. We sub the 5 in for x. And then we would handle the problem as normal. It says 5 plus 2, you know how to add, so we do 5 plus 2, we get 7. Okay, great. So it says substitution, it said evaluating expressions takes two things to understand. The first one is substitution. The second thing is order of operations. The reason is, we'll say it's not just the addition between the two things. We'll say there's a lot of operations going on. We need to have a set order in which to do that. I suggest that you look at order operations from any source that you want. I'll have some that link back to mine as well within your course description. But order of operations, some of you may have heard of something like, please excuse my dear Aunt Sally Lee Rogers or something. I don't know. People have all kinds of things for that stuff nowadays. But, or PEMDAS Lure, or just PEMDAS, some of you have heard. Whatever you want to call it, there is an order in which we do our operations. Because if we didn't have an order, anyone would do whatever they wanted, whatever they felt most comfortable with. So that's why we have this order of operations. So let's take a look at what that is first. So first, we do have a set of parentheses. Real time teaching. We have a set of parentheses or groupings. The second thing that we have is exponents. This is raising to a power. Or taking a root. That's right. Square roots, cube roots are exponents. Yes, I'm not crazy. I'm telling you that's what they are. And some of you have seen that in other classes before, that taking a root can actually be changed to an exponent. Same thing, raising a power, you can raise it to a fractional power, and it's the same as taking a root. So, but it'll be, you can look at some other videos of mine if you'd like to, or other sources in order to see that happening. But after you have your exponents, we look at two operations together to see which one occurs first from left to right. And so that's multiplication and division. And this is done from left to right. The reason again is so we can have that order in the process. Now division is just the inverse of multiplication, so generally that will not matter whenever you're doing it. So that's why these two are grouped together. So after that, last but not least, we have addition, subtraction, as it appears from left to right. Okay, so we have to evaluate expressions. You need to know two things. You need to know how to substitute for a variable given a value for it, and you need to understand how to do the order of operations appropriately. So parentheses or groupings first, exponents second, which include raising to powers or taking roots, multiplication or division, whichever appears first from left to right, and then addition or subtraction, whichever appears first from left to right. Of course, inside of the groupings, you restart your order of operations again based off what's there. Again, still groupings, exponents, multiplication or division, addition, subtraction, left to right for those two. All right, so let's look at two examples and we'll call it done. So, let's say that x equals 5, y equals 4, and z equals 3. And that p plus ph squared minus, sorry, not p, I'm changing this. Let's say that x plus xy squared minus z to the third is the expression we want to evaluate. So x equals 5, y equals 4, and z equals 3. And x plus xy squared minus z to the third power is what we want to find out what the value is. So first things first, we're going to substitute. So if I substitute 5 for x, and I substitute 4 for y, and I substitute 3 for z, we should now be able to evaluate using order of operations. So order of operation tells us to handle our groupings first, which we didn't have any. I added the parentheses there just to make it easier to see the substitution. But, so if we went inside them anyway, there would be nothing left to do, so you'd be done with the parentheses. Okay, what comes next? Exponents. So if we handle our exponents next, we have 4 squared and we have 3 to the third. Well, we'll handle the first one we see, which is the 4 squared. So we get 5 plus 5 times 4 squared is 16, minus 3 to the third power is 27. Recall that exponents just tell you how many times to take this base, or the number, and multiply it times itself. This says 2 times, so this will be 4 times 4. This says 3 times, so this will be 3 times 3 times 3. And that's how I got those values. Okay, well, after that, we look at multiplication or division as it occurs from left to right. Well, there's nothing there. Here we have some multiplication going on, and there's none anywhere else anyway. So 5 times 16 is what we would do next. So we have 5 plus 5 times 16 gives us 80, and then we subtract 27. Okay, cool. Well, what's next? Addition or subtraction as it appears from left to right. Well, 80 plus 5, or 5 plus 80 is 85, minus 27. Okay, great. Well, what's 85 minus 27? Yeah. 58. And you have just evaluated that expression. When x is 5, y is 4, and z is 3, x plus xy squared minus z to the third power is 58. Okay? So we just evaluated expression. Again, remembering the first step was substitution. And then after that, it's order of operations. And you get your result. Okay? Let's look at one more, and we will call it Dunzo. All right, so erase this here. And let's do square root of x squared minus z squared minus 4 squared. So not 4 squared. I have 4 minus y squared and x plus y plus z. Okay, we got a lot going on here, so I made this one up this way. So first things first still, we substitute. So we substitute for values here. We end up with the square root of 5 squared minus 3 squared minus 4 squared all over 5 plus 4 plus 3. Okay? Well, very important to note that whenever you are dividing, like this, the top, the numerator, is one grouping, and the denominator is a separate grouping. So even if you want to do this, you can, and that's perfectly fine. So first things first, we go into this grouping, and then inside of here, we actually have another grouping. This square root is over this entire expression, so therefore, it is another grouping on its own. So we would go in there first before we did anything else. So if we did, we would see that 5 squared is, we would see 5 squared minus 3 squared. And according to that, order of operations would follow, exponents first, and then we would subtract. So we would get parentheses, square root of 5 squared would be 25, minus 3 squared would be 9. And then we have 4 squared over 5 plus 4 plus 3. And I'm going to erase the above to make it a little easier for us to do. Let's have more room. Okay. So going back up, 25 minus 9 is still inside of our grouping. 25 minus 9, it will be 16. So this would be the square root of 16 minus 4 squared over 5 plus 4 plus 3. Now, a lot of times for myself, I would have already added this together because this is its own separate group that has to get done before we can even divide. But just for the sake of us learning and taking it step by step, I'm going to do it this way. All right. So square root of 16 is 4. Minus 4 squared would be 16. All over 5 plus 4 plus 3. Okay. Well, let's subtract that up top. 4 minus 16 gives us negative 12. In the denominator, we get 5 plus 4 plus 3, which will give us 12. Sweet. And what is negative 12 divided by 12? Negative 1. That's right, negative 1. You just evaluated expressions, some pretty complicated ones. Well, I wouldn't call it complicated, but I would say it was tedious and simple. So remember, evaluating expressions, first things first, substitute your values in. Second thing, use order of operations. That's it. And I will see you soon.